Hey everyone, so today we're going to be doing kinematics, more specifically constant acceleration, chapter 10C on your textbook. This topic isn't that difficult, but there's one question, which is on the screen right now, which could be proved to be a challenge for you. So, if you struggle, or that's probably why you're watching this, then yeah, we'll go through a solution today. Question 11, a stationary police motorcycle is passed through a car by a car traveling at 72 km per hour. So you got a motorcycle, police motorcycle. I don't know what they look like or how to draw them. I'll just draw them like this way. And then you got a car, which passes this motorcycle at 72 km per hour. The motorcycle starts in pursuit 3 seconds later. So 3 seconds later, so it's gonna wait 3 seconds and then accelerates constant acceleration for a distance of 300 meters. It reaches a speed of 108 km per hour. So yeah, it's gonna accelerate for 300 meters until it reaches 108 km per hour. And this car right here just travels at 72 km per hour, constant. So 108 km per hour and then maintains that speed after 300 meters. Find the time from when the motorcycle starts pursuit it takes the motorcycle to catch the car. So basically, this is going to be going faster than this car, so eventually the motorcycle should catch the car even if it started late. So yeah, eventually it will catch the car. Right, so the objective of this is to find the time. So, when does it reach the car? And the best way to do this is get your velocity time graph. We're given speed, we're given time, might as well do it, right? So velocity time graph, I'll try to get the straightest graph I can. Velocity, time. Okay, so here's the problem that you have to notice. This is in kilometers per hour, the speed of the the velocity they give you, but they also gave you in terms of meters and seconds. You can't just work with these numbers. You actually have to convert them first, and the best way is converting kilometers per hour into meters per second so that your numbers are smaller. You work with smaller numbers and it just helps a lot. If you want to convert, so the car moving at 72 km per hour, if you want to convert that to meters per second, all you have to do is divide it by 3.6. So velocity of the car, I'll put VC. If you go 72 divided by 3.6, you should get 20 meters per second. And therefore, this is moving at constant velocity. So we're just going to draw 72 or 20 meters per second right there. This car is just going to move there. We'll call it VC of the car. Okay, then the motorcycle starts in pursuit 3 seconds later. Okay, remember, our velocity is now in terms of meters per second, so your time should also be in seconds. And we have him starting at 3. I'll use red. For distance, so it moves for a distance of 300 meters. It reaches a speed of 108. So after 3 seconds, he starts moving, constant acceleration up until there. We don't know the time for this. We can find it soon. But we know he moves the area under the curve, velocity curve, is the distance. He moves 300 meters until he reaches 108 meters per second. 108 kilometers per hour, I mean. So 108 divided by 3.6, we should get 30 meters per second. And of course, maintains constant acceleration from there on. Stated here. Okay, 30 meters per second, and our objective, of course, is to find the time. Before we do that, we need to find what T1 is. To find T1, very simple, use one of your 4 kinematics formula. We know U equals to 0 because the motorcycle starts at rest. V equals to 30 because he goes up to 30 meters per second. And distance equals 300. We want to find time. So which kinematic formula do you use? Use the fourth one. Since this is constant acceleration, you can use those 4. And the formula we should be using is the S equals to half U plus V times T. S we know is 300, U is 0, V is 30, and we don't know what T is. We're solving for that. 300 equals to 30 divided by 2 is 15T, and therefore T equals to 20 seconds. So basically, after 20 seconds, he reaches the 30 meters per second and travel 300 meters. Therefore, if you want to find T1, you add 20 on top of 3. So in this case, we get 23. So yeah, afterwards, guys, you want to find how long it takes for the motorcycle to reach the car. So if you just look at this graph right here, velocity graph, if you want to find when it reaches it, the distance they have to travel must be the same. So how do you find the distance? It's the area under the curve. So we know this area is 300, but you can also, you can find the area under the car. Yeah, so you have a look at this from 3 to 23, the area is 300, but in this case, after 23 seconds, the car would have reached 20 times 23, so 20 times 23, that's 460 meters. So after 23 seconds in, the car has reached 20 times 23, which is 460 meters, whereas the motorcycle has only reached 300. So obviously the motorcycle hasn't covered enough distance to catch the car just yet. So the answer doesn't lie within the triangle of this area from 3 to 23. So we need to keep going further. How much further? We don't know, but we'll set that as big T right here. So that's our answer. If you can find the time, so the area where they equal each other for that time, then you can easily, and then you can solve this question. So how do you do that? Once again, just go get the area for the car, which in this case is 20, which is your velocity, times it by t, which is your time to get your distance. 20 times t, and we let that equals to 300, the area for the 3 to 23 right here, plus t minus 23 to get your length, times it by 30 to get the area for that rectangle right here. Okay, so and then you just solve for t. You do your calculations. 20t equals to 300 plus 30t minus 690. You do all your work here. You bring 20t to this side. You bring 690 and 300 to the other side. You should get 390. And therefore t equals to 39. So yeah, this time is 39. So 39 seconds after the car passes the motorcycle, then the motorcycle reaches the car again. Well, the question though, so if you actually put 39, it's actually wrong, because the question says find the time from when the motorcycle starts pursuit. So it starts pursuit at 3 seconds, after 3 seconds only. So you have to go 39 minus 3. So 39 minus 3 to get your final answer, which is 36 seconds. So after 36 seconds after the pursuit, the motorcycle catches the car. And that's because the area equals each other. So yeah, that's pretty much it for this question, guys. Question 11. If you have any question, leave a comment. And aside from that, thanks for watching, and I'll see you next week.